to n upon ax plus b raised to n. Then if y is equal to sine of bx, then yn is equal to minus 1, oh sorry, not minus 1, b raised to n sine of bx plus n pi by 2. If there is bx plus c, it will not make a difference. Bx plus c will be b raised to n sine bx plus c plus n pi by 2. Similarly, for y is equal to cos of, I'll write down ax plus b now. Yn will be equal to e raised to n cos of ax plus b plus n pi by 2. Last and a very important one. If you have the combination e to the power ax cos of bx sine of bx. So if y is equal to e to the power ax sine bx plus c, then yn will be equal to r raised to n e to the power ax sine of bx plus c plus n theta, where r is equal to under root of a square plus b square and theta is equal to tan inverse of b by a. So these all formulas we have seen in the previous lecture. Now today we will solve examples on these, and then we'll go ahead with the new and very important theorem on which theory questions are asked. So find the nth derivative. Find nth derivative of first one e to the power 2x cos square x sin x. And second one cos x cos 2x cos of 3x. So if y is equal to e to the power 2x cos square x sin x, and I want to find the nth derivative, so we have to convert it to our required form. 1 plus cos theta, we know that 1 plus cos theta is equal to, or 1 plus cos 2 theta is equal to 2 cos square theta. So cos square theta is equal to 1 plus cos 2 theta divided by 2. So y will be equal to e to the power 2x in bracket 1 plus cos of 2 theta divided by 2 sin of x. Let's open the bracket. The first term that we get is e to the power 2x sin x plus 1 by 2 e to the power 2x in bracket cos 2 theta into sin x. Yes, anyone, what can we do now? To convert it to some form where I can take the nth derivative directly. So 1 by 2 e to the power 2x sin x. plus 1 by 2 or e to the power 2x by 2 in bracket. Anyone? How can we convert this cos 2x? Sorry, it has to be x, not.
Multiply by 2 and divide by 2, and then we can make it in the form of sin a plus b minus sin a minus b.
Yes. So what we will get here is 1 by 2 sine of 2x plus x. So that will be 3x minus sine of x. Yes. So now open the bracket. So 1 by 2 I can take completely outside, e to the power 2x sine x plus e to the power 2x sine 3x minus e to the power 2x sine x, and this divided by 2. So now I can take nth derivative of this. So first and third term, e to the power 2x sine x, and the last one is also e to the power 2x sine x. And this is with 1 by 2. So I can manage this e to the power 2x sine of 3x. So 1 minus 1 by 2 is plus 1 by 2 e to the power 2x sine x. Please check the calculation. So now taking nth derivative. Taking nth derivative, or taking n derivatives, what do we get? Yn is equal to 1 by 2 in bracket. What is the value of r here? R is equal to under root 3 square plus 2 square. That is 9 plus 4, 13. Under root 13 raised to n e to the power 2x sine in bracket 3x plus n times uh, theta 1 plus 1 by 2 under root 1 square plus 2 square plus 1 5 under root 5 raised to n e to the power 2x sine of x plus n theta 2. So I can give the values of theta 1 and theta 2 in this
सर वन
square.
बाई सर 1/2 ऑलरेडी कॉमन है, फिर से अंदर लेने की अंदर नहीं लेना.
Why not? There are two 1 by 2's there.
No sir, check out the equation, half of the second equation from the second column.
Sine a cos b. That is, so that will be
No, second equation, one below that.
सर
just a
1/2 ब्रैकेट के अंदर
वन
आएगा
बाय टू
स्क्वायर
ब्रैकेट
ब्रैकेट.
yes.
ऑलरेडी कॉमन दिया है, सो अंदर नहीं आएगा.
Just a minute. Cos 2x sin x. So there is this 1 by 2 which I can adjust. Fine. So I can cancel this one. So this won't be there. No,
No
that's
sir,
what
I
it
mean in that step there is 1 times e raised to 2x sin x plus the whole thing is divided by 2. E
yes,
raised to
that's what I
2x
have
sin
cancelled,
x.
right?
Huh. And
Huh.
then so then
Huh.
both terms will have 1/2. So here in the last equation we have written 1/2 for the second term, which is not needed.
Yes, correct.
Yes sir.
Yes. So where theta 1 is equal to tan inverse of tan inverse of b by a. B by a in the first one is 3 by 2, and theta 2 is equal to tan inverse of um 1 b by 1 by 2. Okay. So the second one, if y is equal to, should I go to the next page? No, if y is equal to cos x, cos 2x, cos 3x. Y is equal to cos x, cos of 2x, cos of 3x. Then, so I can use the same formula twice now. So cos A, cos B, or so y is equal to 1 by 2 cos of 2x in bracket 2 cos x cos 3x. I have multiplied and divided by 2 there. So this will be equal to 1 by 2 cos 2x in bracket 2 cos A cos B, that will be equal to cos of A plus B plus cos of C minus A, which will become 2x. Now you can open the bracket, so that will be 1 by 2 cos 2x cos of 4x plus 1 by 2 cos square 2x. Cos square 2x further can be reduced, and 1 by 2, what I can do again is multiply and divide by 2 in the first term. So this will be 1 by 4 2 cos 2x cos of 4x plus 1 by 2 cos square 2x will be 1 plus cos of 4x divided by 2. So that will be 1 by 4 in bracket cos of a plus b, that will be 6x plus b minus a for 2x plus 1 by 4 in bracket 1 plus cos of 4x. So what y we have got is 1 by 4 in bracket cos 6x plus cos of 4x plus cos of 2x plus 1. So taking n derivatives successively, so yn 1 by 4 being constant will come outside every time. Nth derivative of cos of 6x, that is uh, just a minute. Yes, so that will be cos of 6x plus n pi by 2 into 6 raised to n plus 4 raised to n cos of 4x plus n pi by 2 plus 2 raised to n cos of 2x plus n pi by 2 plus Tarun, what will be the further term? Anirudh Goyal,
Yes, sir. The last term
yes,
will,
what will be the further term?
sir, no, nothing, but this much is the answer.
This much is done. Okay, thank you. It's correct. So one, any number of derivatives of one will become zero. Zero. That is our final answer. Fine. Now what we will do is we'll get to a very important type of examples where I want to find nth derivative of some polynomials like partial using some you have what we say find nth derivative nth derivative of, don't write anything, just concentrate for a while. So what we have is x upon x minus 1 x minus 2. So such type of functions are called rational functions. So I will give a quick summary on the right hand side. So rational functions are the functions of the type f of x upon g of x. Thus f of x comma g of x are polynomials. F of x comma g of x are polynomials. So in that case, what we can do is I can always reduce the polynomial. I mean, to some form where I can take the nth derivative of this. Okay. So what we have to do is we have to convert it. So since it is a polynomial, I can always have like the form like x minus m1, x minus m2. So this kind of thing in the numerator, x minus alpha 1, x minus alpha 2, this kind of thing in the denominator. So how can I convert this? I mean, when I want to solve this, what we do is we convert it using partial fraction. Okay, the partial fraction was something that you did for integration. So you had the form like ax plus b upon x minus alpha 1 x minus alpha 2. So what you did was you converted it to the form a upon x minus alpha 1 plus b upon x minus alpha 2, right? And then integrating this was easier. In the similar manner, this term is also feasible or convenient to take the nth derivative because we have the formula 1 upon ax plus b. We know the formula for finding nth derivative of 1 upon ax plus b. If there is some constant, say capital A, what I can do is I can write this down as a in bracket 1 upon ax plus b, and then I can take the nth derivative. So our task is to convert the given rational function to this form 1 upon ax plus b. So what are the conditions? Can I use partial fraction anytime or there is any condition there?
The power of denominator should be
Numerator
greater
of
than
power
the
should be
numerator.
less than or equal to less than the power of denominator.
Power of
Yes.
numerator should be greater than
So power of numerator has to be smaller than the power of denominator. In that case, what I can do is I can use the partial fraction. So first thing that you have to do is you have to look at the power. So if degree of g of x is greater than degree of f of x, then we can use partial fraction. Then we can use partial fraction. Or the other cases, if degree of f of x is greater than degree of g of x, then what can we do?
Division.
Which division?
Uh, Polynomial division or
polynomial
Long,
division.
long
Long
division we
division.
can
long
use.
division.
Yes.
Then using long division, divide we have to divide using long division, and later what we will get is r of x upon g of x, right, plus some q of x. This kind of expression we will get, in which now g of x, by division algorithm itself, degree of g of x will be smaller than degree of r of x. Okay, so if the degree is not degree of numerator isn't smaller, then you do the long division, and then you will get the required condition, and then use the partial fraction. If it is already less, then you can directly use the partial fraction and we can go ahead. Fine. So let's solve the question that is given there. So if I want to use the partial fraction in this case, already degree of numerator is smaller than degree of denominator. So what I can do is I can directly use the partial fraction. So x upon x minus 1, x minus 2, how I have to write it down as a upon x minus 1 plus b upon x minus 2. So we do the cross multiplication, denominators will get cancelled out, and what we have is a into x minus 2 plus b into x minus 1. So if you put x is equal to 1, then a will become minus 1. Put x is equal to 2, then b will become 2. Let's check the calculation. So what we have is y is equal to 2 upon x minus 2 minus 1 upon x minus 1. So once we have got this, I can take n derivatives. So differentiating n times successively. So differentiating n times, we get yn will be equal to 2 being constant will always come outside, and nth derivative of 1 upon x minus 2 is minus 1 raised to n into n factorial upon x minus 2 raised to n plus 1 minus minus 1 raised to n factorial upon x minus 1 raised to n plus 1. Fine. That is our final solution. Any problem you can ask, or else I'll go ahead.
No, sir.
Second, find nth derivative of y is equal to 2x plus 3 upon 5x plus 7. So in this case, degree of numerator is equal to the degree of denominator. So one method will work. I mean, you do the long division and you can go ahead. Another shortcut method is that you adjust the denominator in the numerator. So what do we have? Y is equal to 2x plus 3 upon 5x plus 7. So somehow what I will do is I will adjust the denominator in the numerator, which means that I will make 5x plus 7 in the numerator so that it becomes easier for me. So what I will do is I'll take 2 common first of all from the numerator and multiply and divide by 5. So when I take 2 common, what do we get? X plus 3 by 2 upon 5x plus 7, right? Now multiply by 5 and divide by 5 in the numerator. So 2 by 5 in bracket 5x plus 15 by 2 divided by 5x plus 7. So y will be equal to 2 by 5 in bracket 5x plus 15 by 2 is 7.5. So what I can do is 7 plus 1 by 2, total divided by 5x plus 7. Now this is 2 by 5 in bracket 1 plus 1 by 2 in bracket 1 upon 5x plus 7. Then let's just open the bracket. So what we have, y is equal to 2 by 5 plus 1 by 5 in bracket 1 upon 5x plus 7. So taking n derivative. So we get yn is equal to 0 plus 1 by 5 minus 1 raised to n factorial 5 raised to n upon 5x plus 7 raised to n plus 1. The final solution. Fine. Any problem? Consider no. Go ahead. Find and prove that simply. Prove that the value of nth differential coefficient, the value of nth differential coefficient of x cube upon x square minus 1 for x is equal to 0 is 0. If n is even and minus n factorial if n is odd and greater than 1. Right? So what we have to do is I have to find out the nth derivative. Okay, and I have to show that agar n is even, then the answer is becoming 0. If n is odd, then answer is becoming minus n factorial. And how do we do that? Is by taking nth derivative of this x cube upon x square minus 1. So y is equal to x cube upon x square minus 1. So as I can see that the degree of numerator is greater than the degree of denominator, what we do is we do the long division. And long division is x square minus 1. I have to divide x cube. So multiply by x. What do we have? X cube minus x. Minus sign is minus plus. Get cancelled out. And what we have is x. So further division is not possible. So what we do is I can write down x cube as x into x square minus 1 plus x and total divided by x square minus 1. So this is when I separate, what we have is x plus x upon x square minus 1 I can write as x plus 1 x minus 1. So this is y. Now I can use the partial fraction for the second term. So what we have to do is I have to write down x upon x plus 1 x minus 1 as a upon x plus 1 plus b upon x minus 1.
सर डायरेक्ट +1 -1 भी कर सकते हैं ना ऊपर.
Yes, of course you can do that. A into x minus 1 plus b into x plus 1, and x is equal to 1. Then b will become 1 by 2. Put x is equal to minus 1. Then a will become minus 1 is equal to minus 2. A is equal to plus 1 by 2. Okay. So what do we have? Y is equal to x plus 1 by 2 in bracket 1 upon x plus 1 plus 1 upon x minus 1. We have got this. Now you take any number of derivatives. So once we have this, taking n derivatives successively. When differentiating n times. So what do we get? Yn is equal to if n is greater than 1, so I will consider the condition n greater than 1. So first derivative will be 1 and second derivative, the first term will become 0. So 1 by 2 in bracket minus 1 raised to n into n factorial upon x plus 1 raised to n plus 1 plus minus 1 raised to n into n factorial x minus 1 raised to n plus 1. So what I can do here is I can write this down as 1 by 2 minus 1 raised to n into n factorial in bracket 1 upon x plus 1 raised to n plus 1 plus 1 upon x minus 1 raised to n plus 1. So this is your yn. Now what I have to show? Nth differential coefficient of this for x is equal to 0. Okay. So what we will do is we will put x is equal to 0. So the notation for this is yn at x is equal to 0. And later we will talk about n even and odd. So yn at x is equal to 0 is equal to 1 by 2 minus 1 raised to n factorial in bracket 1 upon 1 raised to n. No matter what is this n, this will become 1 plus 1 upon minus 1 raised to n plus 1. Right? Now if n is even, what will happen? Minus 1 raised to even plus 1.
Zero.
So what will have yn at x equal to 0 is equal to 1 by 2 minus 1 raised to n factorial in bracket 1, and this will become minus 1. So in this case what I can write is 1 upon minus 1. Since you will have even number plus 1, that will become odd. Minus 1 raised to odd number is minus 1. So the total answer will become 0 if n is odd. If n is odd, then yn at x equal to 0 will be equal to 1 by 2 minus 1 raised to n factorial in bracket 1 minus 1 raised to odd number plus 1, that will become odd. So that will become plus 1, right? So this and this will get cancelled out. Minus 1 raised to odd number outside will also become minus 1. So that is minus of n factorial since this number is odd. Clear?
Yes, sir.
So that's all for today. I'll just download the attendance. Okay, fine. Next lecture will be tutorial, and the syllabus for the tutorial, I think in the last tutorial we have covered up to Cayley-Hamilton theorem, right?
Yes,
Yes,
sir.
sir.
So in this session, we will cover the remaining part, which is our applications of matrices and this successive differentiation till today. And please don't consider it as a test. Okay, don't consider it as a test because